Okay, I'm going to talk about two of the concepts that are going to be on the quiz Monday that I feel like people are a little concerned about. This is not everything that's going to be on the quiz, it's just the two things, like I said, that people were most worried about. Function notation and solving polynomial equations. We'll see if I can get through these in a reasonable amount of time. Alright, so function notation. Let's go with blue. So f of x equals this expression. So that means that whenever you see f and then parentheses, okay, in this problem, in this context, it is referring to this right here. It is a function that's actually the quadratic function. It's a polynomial function, but more specifically quadratic. Anyway, so what we can do is f of -3, that just replaces the x everywhere. The -3 does. Okay? So we have 4x squared minus 5x, 4 times whatever squared minus 5 times whatever. In fact, heck, even though that's not really terribly nice looking, I want to make a point here. It's the same throughout. All three of these problems are basically the same. Okay? Although that's not 100% true for this guy. There's going to be something else going on. So bear with me. Alright? So what you sense the function is f of x equals 4x squared minus 5x. F of whatever is 4 times that whatever squared minus 5 times that whatever. So in this case, it's -3. Oh, that was horrible. -3, -3. Okay. Alright, so you just keep on rolling with that and actually do -3 squared, so it's 4 times 9 plus 15, alright, minus negative, double negative, so you do plus, and so it's 36 plus 15, so whatever that is, 46, 51, alright. So when you plug in f of -3, notice you get a number. Alright, if we're talking about graphs, it means when x is -3, the y value is 51. Alright, so this is more abstract of an idea, and we'll talk more about this probably later in the year, but what you do is similar. Alright, you just replace x with b minus 2. So see how if I can squeeze this in here. B minus 2, b minus 2. Okay? That's a minus. Oh my goodness, kind of bad looking. Let's see if I rotate that, make it a little better. That still looks horrible. Anyway, b minus 2. So how do you handle that? Well, it's just an algebra problem now, as opposed to, once you plug in the -3, you're just doing arithmetic. Here you're just doing algebra. So you get 4, and then b minus 2 squared is a FOIL problem. So it's b minus 2 times b minus 2. That's one way to think of it. And so you get b minus 2 squared, which is b squared, minus 2b, minus another 2b, so it's minus 4b total, and then plus 4. Okay? Minus 5b plus 10. Okay? Then you continue with the simplification. Let me move this down south a little bit more. Okay, we get equals, oops, lost my pen, equals 4b squared minus 16b plus 8. And we still have these same last two terms, and then finally we can combine these like terms again, or combine these like terms. If we get 4b squared, let's see, minus 21b plus 18. And there you go. Okay? So f, all f does is tell you what formula is relevant. The letter f here stands for function, but whatever it is, if the context is it's something, that it's function notation, this is not multiplication, this is not f times x, Okay? This is not f times negative 3. This is not f times b minus 2. It's not that. Alright? It is just letting you know that this is the formula you're going to use. So f of t is basically the same thing here, only with t instead of x. Okay? Oops, that's not right. T squared t, okay? And then the difference is, kind of wanted to, it's 5 times f of t. So this is f of t here, okay? It's supposed to be a t. It kind of doesn't look like it. There we go, that's a little better. Okay? It's 5 times f of t. So I have to put the 5 there. So it's 5 times f of t. So it works out to be 20 t squared minus 25t. And there you go. There's function notation. Hopefully that is helpful. Definitely be a couple of those on Quiz Monday. So here is the other thing I wanted to go over. Solving polynomial equations. And it's all by factoring. Alright? And it may be a little quadratic formula actually. So there's 3 types, and actually this will contain both types, or 2 types, and then this is a third one here. So this is, there's 3 types. When I say there's 3 types, there's kind of 3 new types of problems that we ran into with this. Alright, we've actually done this topic before, but it was only quadratics. Alright, so this is the same topic, really, only now there's some more complicated problems, potentially. And that's what's going on here with both of these. So, yeah. So, whenever you're trying to solve something by factoring, your first move is to look for a GCF. And in a lot of problems there isn't one. However, in this problem here there is. 2x squared is the GCF. So you can factor out a 2x squared, and you're left with x cubed minus 64. And that equals 0. Okay? So then here, what's up is that, okay, we have 2 factors now. If you've been, you may have noticed that, well, this factor is going to give us an answer. It's going to give us, one of the answers is that x equals 0. We'll get back to that. All right, and then the other answers are going to come from this guy. So 2x squared times, well, this guy is a difference of cubes. So this is, the 2 ideas in this problem, the 2 types of problems that I'm trying to communicate with this one problem is that a lot of times you have to factor out a GCF, and then here's how you handle difference of square, or difference of cubes in this case. So it's x cubed minus 4 cubed. So 64 is 4 cubed. Okay? 4 times 4 times 4 gives us 64. So if we get the formula, you might want to look at your note, you might want to pause it, get your notes or something to refer to the formula here. X cubed minus 64. X cubed minus 4 cubed. So it's x minus 4, because that's what's getting cubed. It's what's getting cubed first minus what's getting cubed second. And then you can use this to kind of figure out what goes in the rest, because you can refer to it. It's x squared, it's the first thing squared, plus first thing times second thing. Okay, and I said that backwards, but x times 4, first thing times second thing. So x times 4, or 4x, and then plus the second thing squared, which is 16. Okay? So 3 factors. Okay? So you set them all equal to 0. Okay? Let me actually pause and move this out of the way, because this is going to take up some space here. Okay? So 2x squared equals 0. X minus 4 equals 0. And the x squared plus 4x plus 16. Oh my goodness, plus 16 equals 0. So you have these 3 problems. Okay, 2 of them are pretty straightforward. If 2x squared equals 0, x has to equal 0. So 2x squared equals 0, so x equals 0. Okay, x equals 4. because x minus 4 is 0. Okay, it's supposed to be a 4. Hopefully you can read that. And then this is the hard one. And that looks like, doesn't look like a 0. Let me fix that. Boom. Alright, so this is the quadratic equation. This is not factorable. If you try to AC method this sucker, there's no way. If you try to guess and check, whatever terminology you use, whatever, reverse FOIL, whatever you call it, whatever you choose to call it. So you got to go through the quadratic formula. So I'm just going to write it all out. Okay, I'm going to pause and put it out there. Okay, so there you go. Quadratic formula. Net the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Alright? And then, so we simplify. And what's up is that this will always be, in these problems at least, in these different 6 sum or cubes problems, an imaginary answer. You'll have complex solutions here. Always happens. So square root of, turns out to be negative 48 all over 2. Alright, and so we simplify this, and this problem keeps on getting longer and longer. We get x equals negative 2 plus or minus, so we split it up to 2. Negative 4 over 2 is negative 2. Still divide by 2 in the second half. The square root of negative 48 works out to be 4i, okay, times radical 3. Okay. Okay, so how did I do that? 48 is 16 times 3. So square root of 16 times square root of 3 is square root of 16, 4. Square root of 3 is square root of 3. The negative throws an I out in front. Alright? And then, so last but not least, we get negative 2 plus or minus 2i radical 3. 3, there we go. Alright, so then the last type of problem that I have 3 minutes to squeeze in, and we'll see how that goes. Quadratic in form. Okay? So if it's quadratic in form, we get, it's like something squared minus that same thing plus 6. This is quadratic in form. Alright? So this is x squared squared minus x squared plus 6. Okay, so we can factor this with some sort of guess and check method, AC method. I'm just going to cut right to the chase how this would factor. Alright, so it factors like that. Okay? And I didn't really pick these numbers very well, but it doesn't really matter actually. Alright, so I just cheated and typed it out. If you FOIL that out, you get the same thing we started with. Alright, so this is as factors as we can get. Alright, it looks kind of like a difference. This is a difference of squares, well, it looks like difference of squares, but it's not quite because 3 isn't a perfect square. So what you can do, you can still do it though. You're still seeing how to do problems like this. You just set each factor equals 0, so you have x squared minus 3 equals 0. And x squared plus 2 equals 0. Okay? That's horrible. Alright, so I cheated a little bit. I fixed it. But anyway, x squared minus 3 equals 0, x squared plus 2 equals 0. You can solve both of these with what's called the square root method. Alright, so you add 3 to both sides. X squared equals 3. And so x equals plus or minus the square root of whatever is over there, in this case, just square root of 3. So you get the 2 irrational solutions. Real numbers, but irrational. Alright, and same thing over here, same concept. Square root method. And now you're going to get imaginary answers. X squared equals negative 2. And so x equals plus or minus I radical 2. Okay, because it would be square root of negative 2. You don't square root, you don't leave the negative in there. It's represented by an I, because I is the square root of negative 1. Alright, so there you go. 1, 2, 3, 4 answers. 2 of them are imaginary, 2 of them are real. There you go. Hopefully that should be helpful for Monday.